So we're going to look at how we write our aims, and something that we probably haven't done as well as we could have to date. Aims should be a concise statement about what the overall goal of the experiment is. And a general formula for how to do that in a pretty concise way is to follow this template. One sentence. To investigate the effect that blur has on blur. And what do you think the first blur would be in our reports? Just conductivity. Okay. If I was to do an experiment on dropping ball heights, so if I was to drop a ball at 50 centimetres, 1 metre, 150, 2 metres, and see how that impacted bounce height, to investigate the effect that, what?
Height. Would it be?
What height? Drop or bounce? Drop height has on bounce height, correct? Can we maybe think of some independent and dependent variable terms that pop up here?
Thickness.
Yes, so in this case it'll be thickness, but I'm not going to put that down. So to investigate the effect that the independent variable, I can't spell, independent V, I'm just going to put independent V, has on the dependent V. Do I need to write what V stands for, or can we figure that out? V means variable. Okay, so as a general rule, when we're writing aims, the aim of every experiment is to see the impact that the independent variable has on the dependent variable. Happy with that? The hypothesis. Then also notice with my aim before I go any further, I didn't write the aim of the experiment is. That's fairly implied when I write aim. So try and keep it as concise and as we don't need extra words for the sake of words. Hypothesis, the big trap here is writing I predict or I expect. Third person past tense. It is or was, I don't mind. Past tense means was, but because you're predicting, I can sort of see that it should be future tense. It is expected that as So as you change what? You don't always have to be increasing or decreasing. Yes. So it is expected that as the independent variable increases, the dependent variable will, and then obviously you pick the one that applies to you. Now that's a pretty very basic style of hypothesis. We're getting now towards the point where I'd expect us to identify the relationship that we expect. So it's not just about increasing or decreasing, but also about describing how you expect it to increase and decrease. This is expected to follow it could be a linear trend, a parabolic trend, an inverse squared trend, a square root trend, a logarithmic trend, an exponential trend. You pick the type of relationship you're expecting. How will you know what type of relationship to expect?
Regardless.
Yes.
Based on whether it remains the same, increases or decreases.
Well, let's look at the equation F equals ma, right? That's our mousetrap. That was our mousetrap Newton's second law. What were the variables we were changing? Our independent variable was mass and our dependent variable was acceleration. So if we make mass the subject, so we divide both sides by A, what's the relationship that we're expecting between mass and acceleration? Is that going to be a linear trend? Okay, well, let's go the other way. Let's make acceleration the subject. F equals ma, divide both sides by m. Okay, so acceleration equals F over m. So as I double my mass, do I expect my acceleration to double? No, so that's not a linear trend. Do I expect it to go up by 2 squared? So it's not a quadratic trend. What type of trend is that? An inverse trend, correct? So we use the equation to tell us what relationship we're expecting. Happy with that? Was that what we saw generally in our reports? Did we get a perfectly inverse trend? And that's where the discussion comes in. Sweet. So an A student will link their hypothesis to an expected trend and the equation. Do I expect you to be absolute superstars at that first off? Absolutely not. But if you start doing it now, it should progressively get easier over time. And hopefully by the second or third report we do, we should be confident at identifying what trend we're expecting and being able to explain why we expect that trend.